Okay, so up to this point, you've really only been working with degrees. We're going to work with something called radians because what we're going to do is refer to rotations around a circle. Okay, so in other words, pi is going to come to be very important. The reason pi is important is because it's a value we use to calculate circumference of a circle. Okay, if we should start with degrees. Okay, so if I'm in degrees and I want to turn my term into a radian, I take my degree value. Let's say it's 180. Okay, we'll do it on the side here just because it'll be an easy one to work with. So if I have 180 degrees and I want to change it into radians, I need to multiply by pi over 180 degrees, or 180. Okay, we really don't need degrees, just think of it like that. So 180 times pi divided by 180. Do you know what that's going to become? Okay, well, it'll become 180 pi divided by 180. The 180s cancel out, and we're left with just pi. So in other words, we have 1 pi radians. Okay, and we're going to talk about how that fits in a circle. And if we wanted to vice versa, go from radians to degrees, we would multiply by the reciprocal of what we had, 180 degrees divided by pi. 1 radian is commonly known as 57.3 degrees, or a lot easier to look at it is 180 divided by pi. Okay, let's actually start drawing these things so it makes sense to you. So you're probably like, well, what are you talking about in terms of pi? Well, with our system, remember used to the CAST system, so here are C, A, S, T. Do you remember this? Mm-hmm. Yeah, and this is quadrant 1, quadrant 2, quadrant 3, and then quadrant 4. That's familiar? Mm-hmm. Okay, good. So we have this information here. Essentially, this is 0 degrees. This would be 90 degrees, right? If I drew an angle to here, this would be 180 degrees. This would be 270 degrees. And then if we got all the way back here, 360 degrees again, right? That'd be a full rotation of a circle. Well, a full rotation of a circle, being 360 degrees, that actual distance around the circle is the same as the distance around a circle is known as circumference. And circumference is 2 pi r, or pi times diameter, okay? But 2 pi r, okay? And the reason we're talking about r is because now what we're going to be doing is we're going to be drawing an arm that's going to rotate around. So let's say we have this arm here. This is considered a radius. And this radius is going to go all the way around. So we're going to start here. It comes up to 90, goes to 180, around to 270, and then back to 360. This is r, this measurement. It's always considered the radius of some circle. So let's say we put a circle on here. Okay, and we'll try to move r around it. I'll try to be as exact as possible. Okay, so this is a radius. And in other words, to get to here, we're going to figure out how much of pi that is. Well, we know to go all the way around the circle with a radius, we got to go essentially, according to our formula, we take the radius and we multiply by 2 pi. So to make a full rotation around a circle, all the way around this, would be 2 pi. Okay? So in other words, in radians, this is known as 2 pi. Okay? Obviously, it starts at 0 also. So 0, and then all the way around would be 2 pi. Okay? Well, this is only a quarter of the way. Okay? And in fact, to make this easier, let's go halfway. So let's say we were to take that radian arm, and we went half of 2 pi. So just to 180 degrees. What would half of 2 pi be?
90.
Think of it like this. 2 pi divided by 2, what does it become?
Pi.
Just pi. Okay. So that's how we represent that as a radian. 180 degrees is also known as pi. Okay. Now let's go to 90. Let's say we didn't actually take this all the way around this arm, and we only took it halfway to 180. What would half of pi be?
1 over 2 pi?
Yeah, or essentially pi over 2. Okay, same thing. And then let's say we did it 3/4 of the way. What would that be known as a fraction? Let's say we did it over 2 pi. This is, if this is 1 pi, right? This would be considered what? And then if that's 2 pi?
1.5.
1.5, or is also known as a fraction, is 3 over 2. Okay, so 270 is also known as 3 over 2. Okay, or 3 pi over 2. Let's not what I was looking for. So we have that information. We essentially know what 0, 90, 180, 270, and 360 are in terms of radians. But what we're actually going to be working on is special triangles. Okay, we're going to be using a lot of special triangle rules. So there are two major special triangles we need to remember when we go through this. And I'm just going to quickly put them up on the side here. See if you remember these measurements. If this is 90 degrees, and this is 45, and this is 45, do you know what the measures of this triangle is in terms of a ratio? Do you recall this at all? No?
Yeah, I don't remember that.
Okay, well this side length will be 1, this side length will be 1, and this one will be root 2. Okay? Same idea here. If this is 60, this is 30 degrees. Okay? This is going to be 1, this will be root 3 this side, and this measurement will be 2. Okay? So we're going to be using these special triangles for specific angles. These measurements are going to help us a lot with what we're doing. So we'll start with the easiest ones. Okay? So we'll go back to our radian arm again. We'll move it around. Say we're starting at 0, and this would be considered going about 45 degrees, right? So let's say, here we go, this is 45 degrees. We'll put a little nick here. At 45 degrees, what would that be in terms of a radian, would you say? If we know that this is pi over 2 and this is 0, don't worry about that. What do you think that would be as a radian or a fraction? Because that fraction is 1 over 2, right?
I don't know.
Well, if this is half of pi over 2, in other words, think of it like taking pi over 2 and then dividing it by half. So in other words, multiplying the bottom by 2. What are we going to get?
Pi over 4.
That's right. So in other words, we're moving half of that distance. So this distance at 45 degrees is known as pi over 4 in radians. Okay? Using that same radian arm, we get to about halfway here. Okay? This being, I guess I should really draw lines here, so I'll keep that one there. We have a new one here. This one being, again, we always measure from the x-axis. So this being 45 degrees. What would this be as a radian? This is essentially 3/4 of the whole way, right? So what would that be as a fraction? This would be over 2. Nope, it's not going to be over 2.
Over... Not
Well, if we have 1, 2, 3, 4 parts of a fraction, what's it going to be over?
3, 4.
4. And then we've gone 1, 2, 3 of them. So we've gone 3... Yeah, 3 pi over 4. We've gone 3/4 of the way. Okay? Now, I know that's 45 degrees here, but technically what that is, starting from the beginning, is 135 degrees. Okay? So this is also known as 135 degrees. This one's known as 45 degrees. Okay? So we've taken that there. Let's get another arm. Well, let's say we've gone to this part here. Again, we'll try to do it in fourths. With this mentality, well, if we would have got 1/4, so this is another, say we're doing fourths, it's an improper fraction. This would be 5 pi over 4. Okay? And then if we add another 1/4 of the way here, okay, this is going to be, if that's 5 pi over 4, 6, 7 pi over 4. Okay? And that would be another 45 degrees. These are all considered 45-degree angles from here. Okay, so these are a couple more. Now the other two major ones we got to talk about are at 30 degrees and 60 degrees. Okay, and then here's another 60 degrees and 30 degrees. 30 degrees, 60 degrees, 60 degrees, 30 degrees. So these are going to be all the major measurements. Okay, it's going to look like that. I'm actually going to bring up a wheel for you. Okay, because we actually have wheels of this already done. And we'll do them with a unit circle with all the coordinates together. So I'm going to actually get a new page going. And this is going to help us here. Now this one has a lot of information. And if you notice, there's our 2 pi. Here's our pi over 2. Here's our pi. Here's our 3 pi over 2. Okay, we have those major measurements. Like we said, we had pi over 4 for 45 degrees, 3 pi over 4 for 135, 5 pi over 4 for 225, that's adding 45 to 180, and 7 pi over 4 for 315. Here are the other ones, okay? Pi over 6 is 30 degrees. Pi over 3 is 60 degrees, okay? And essentially, this wheel runs through all of them. The last thing you're going to work on is the special triangle actual measurements here. And those special triangle measurements are actually turning these into triangles and finding coordinates to them. So we'll do the last here, 120, 150. That's what these are as radians, okay? They're just going through. Oh, they didn't put the measurement up here. Well, it should be 210, I think. Yeah. That'll be that. That'll be that. Okay, so those are our measurements. And now the reason that they have these coordinates here, those coordinates, what they're doing is telling you if the radius was 1. Okay, let's say our radius is equal to 1. So we have a circle that has a radius of 1 all the way around. This measurement is 1. Okay, well, if we were to create a right angle triangle out of this, our radius is 1. Well, if this is 30 degrees, this should be 30 degrees. This is 60 degrees. Okay, remember I told you we always measure from the bottom of this? Well, knowing that triangle, if this is the radius, okay, what this is saying here is this distance is root 3 over 2, and this y distance is a half. That's what they're telling you. They're telling you what these parts of the triangles are. So all of these are setting up parts of a triangle. That's what essentially radians are. But we're getting a little ahead of ourselves. Let's go back. Really what we're going to focus on today, and I want you to try, is actually turning radians into degrees and degrees into radians. What we're doing is we're just talking about how radians relate to a circle and those special triangles, okay? So I want you to actually try to convert some. Did a bit of a whole course there on it.